Alrighty, happy Wednesday. So this is our last topic. Got a little bit of everything here, so we're not going to get into everything here, but a little bit of NumPy, a little bit of Pandas, a little bit of MatPlotLib. These are all different libraries that we can use to do cool things. So NumPy or NumPy, I forget how people say it. I like NumPy, but it's probably wrong, is fundamental to doing mathematical things with numbers. Pandas is a way for us to work with data and organize data in a way that's pretty common. And then MatPlotLib, I think I showed you real briefly a bunch of weeks ago. You can chart just about anything you want to. Super cool. We'll do some fun graphs next semester. But the idea with data science, you can read through some of the first, here's what data science is later as we go. And then Jupyter Notebooks is also really fun too. So with Jupyter Notebooks, it's a different way of organizing, storing, sharing code. I'm quite fond of PyCharm because I like my integrated development environment. I like the debugging tools. I like all these things. But Jupyter is really fun because it gives you this environment where you've got code and you've got other pieces. So essentially you can add comments here in Markdown. It's a very common format here. And then you can actually get the results back out. So if you're putting together some data analysis or running something step by step, you can share these Jupyter notebooks. You can go through, I think, did I show you, was it Chase Bank? One of the banks had a Jupyter notebook thing. Right, we looked at that real briefly. And now you can go through and do that. So this is a really fun, pretty common way of doing stuff in Python. I think you'll use Jupyter in some of the other classes. Again, I just like the integrated development environment a little bit better, just for the things that we're doing for our purposes. Excuse me. But Jupyter is lots of fun here. So we'll go over to some of the libraries here. These are more fun. We can actually play with a little bit more. We start a new project. So this is just libraries. And again, in our virtual environment, when we install them, they're added to this virtual environment. They're not added to our base Python install. So if you want them to be added to your base Python install, you can go do that as well. It just depends on which environment you're using. These ones are probably pretty safe. I've got no concerns with these libraries, but as you start experimenting and playing with other things, you want to be a little bit more careful. So using the virtual environments is pretty helpful here. And you don't always get this light bulb to work here. So if we want to import NumPy here, usually it'll work for us here. So, oh hey, do I want to install the package? If you don't get that, you can go install it yourself. So if you go to your settings here, and then you go to your project libraries, Python interpreter here. Here is the list of all the packages that are installed. I hit record, right? Okay, good. Let's have a moment. So here you can go, hey, I want to install a package, and this gives you a visual view for how we can go install things. And in here you can go find anything and everything. And this is where it gets a little weird, what are all these other things? You don't have to worry about most of them here. So you find the one, make sure it's the correct one. They're pretty good about this. This is the main Python library here, and you can go install the package directly here. So if the light bulb isn't working, which it doesn't always, it usually does for us. PyCharm's pretty good, but you can always go install stuff here. If you want MatPlotLib, we can go find MatPlotLib, go install this one here, Pandas. I don't know why it's called Pandas, but I love it. Pandas are awesome. So lots of fun things out here. You can go install them by hand if you want, and then it's going to install it to this library's virtual environment, right? So you can, each one of these has different ones. So I think with the miscellaneous one, right, we installed request. So you can see, hey, this package has been installed in this clone, essentially, of Python here, just to keep things cleaner here. That's what that one does for us here. So we're going to install NumPy, right? And I just like the little light bulb here. It should do it all for us. It's give a little progress bar down the bottom, goes and downloads it here. Oh, that's nice of them. They say they support NumPy, and we should pay for their paid version because some of the money we give them will go to NumPy, right? It's actually kind of cool to support big libraries like that. NumPy. NumPy.org. Yeah, an open source project. It's amazing people go and spend time on these things here without getting paid to do it. But that's one of the cool things I always liked about the computer industry. And just people will do things because they like it here. It does cause a little bit of issues here. And then, if you take some security classes, people get scared about this sort of stuff here. But in general, I think it's a pretty good model with open source. All right, so we've got NumPy here. We can go through, we can do a couple quick little things here. So one of the things you can do is you can turn them into arrays pretty quickly. So you'll, using a list here, it turns them into specifically an array. It's a slightly different type. For our purposes, it doesn't matter too much here, but NumPy uses arrays, not lists. So everything we're going to do gets turned into an array. It's not too big of a deal for us with that. And then you can make an n-dimensional array here, right? So we did list of lists, these like two-dimensional lists here. Same idea here, but it's this array of arrays. Right? We've done those before with our little 2D list when we did our game here. Then you can start dealing with specific axes. So this is where it gets a little bit nicer if you're doing anything with matrices. I think you'll get into that in your linear algebra class. You do a lot more with matrices, right? Okay, I don't know if you're there yet or not. But you can get specific, hey, I want this specific axis or axis here, or I want to just get a specific axis and I want to sort on axis 0. You can be very specific around how we're manipulating and modifying these matrices. So tons of cool things we can do with that here. We're not even going to do all of these here. Just know that NumPy can do a lot of cool things here. Keep it in the back of your toolkit here. We can create them that are empty, create them with ones, fill with certain values here. You can get a specific row and index. So instead of it being row index and then column index as two different, like we get the first list, which is the row, and we get the next list, you just get a comma separate here. And it's, you don't need to keep it in your head, but go look up. So it works a little bit differently to get a specific element, right, out of an array in NumPy versus a list of lists like you would do just in raw Python. Being able to sort on a given axis is really cool. Flattened versions of arrays. Right, so if we don't want it as two-dimensional, we can go and flatten it, depending on what we're doing here. Transposing is really cool. So just lots of cool things we can do with these. Then we get all sorts of other fun mathematical operations we get in NumPy, right? Wouldn't it be nice if we could just get the median value, right? Or the standard deviation? Oh, hey, look, we didn't have to do it by hand. NumPy does it for us. These sorts of things are lots of things we've done before. You can get the dot product of any two arrays. It's super handy if you're doing matrix things like that. Oh, discrete structures. You do stuff with arrays. It's really tedious to multiply arrays or things like that, or vectors to get your arrays, but we can do it. So cross products, dot products, all sorts of fun things here, all built in. So basically, if there's some sort of thing you want to do, programmers have given you a library for it, right? Because all those things you would do in math land, right? There's a tool to do that for us, that sort of thing. All right, so NumPy's cool. Pandas is another fun one here. So this idea lets us organize and work with data, and its core unit is called a data frame. So a data frame is a way of storing this. So it's basically like a 2D array, but we work with it as a data frame, is how we think of it here. So we have indexes, which are the row labels. So like here's the row label, so index 0, index 1, index 2, and then the column labels are just columns, right? So here's the row and then columns. Works out well. Everybody likes to name things differently. It's okay. So to make a row and column list here, right, we've got our indexes. So I always start at 0 because that's the right way to count. And then our column labels. And it's actually nice to label these things and have a specific label so you know what these things are, which is pretty cool. So you can create your labels there. So let's import pandas. Pandas. There we go. I think that ought to do it. Install pandas. And then once you've installed it once, PyCharm will keep this in your cache, so it doesn't have to go out and re-download it from the internet before. So any other project you create, when you import these things, it'll be a lot faster because it already has it, which is really nice. So they're a little bit different, but not too much. So data frames are always two-dimensional. Right? So we're always just the 2D array. That's our basic shape that we use here versus our NumPy arrays, which could be n-dimensional, right? Data frames may have different types here, but arrays can only have a single type. So when we're working with an array, it only has a single type of data here, but this one, our data frame columns can have different types. So we had, hey, this is a column of strings, this is a column of strings, this is a column of integers. Right? So we've got some other values we can work with here. Right? Integers, strings, or other types, and then, but our indices need to be integers, so we can access them here. So you can make a little data frame with a data frame call. So this is a call to the init method, right, or init function of data frame, and you give it, here's some data, here's the columns, here's your indices. It's a little annoying, you have to give it separate here. Not too big of a deal, but you can work it out. So here's the data we're giving it, and then we're labeling our columns. These are not really good labels here, right? It'd be nice to know what these things were, but again, it's just kind of nonsense. But each column, right, has its own set of data types. So these ones are booleans, these ones look like integers, these look like floats, these look like strings. You can be specific about the types here. And then you get a nice little printout here, which is really nice. And it prints it really pretty. So you don't have to deal with any sort of ugly formatting or things like that. You just call the shape of it here. We can print its shape. We'll just steal this one here, right? And for some reason, they don't like typing the whole thing out. So you can use this as when you import things to give it a short name. I don't know why. PD is, I guess, is faster than Pandas, but everybody does this. I've never seen anybody not use NP and PD for these sorts of abbreviations. So when you go and import them here, and I should specify, I'm stealing it from here, right? That's important. Give it a quick little run, and we get our nice little printout. And again, here's our shape. So the shape of it here, and it's not even a function, it's just this is the attribute shape here, gives us, this is what it looks like. We can kind of explore it really nice. That's a quick way to go through. And then when you're dealing with large amounts of data, sometimes you just want subsets. Right? It might be a really large data frame. If you've ever seen giant Excel spreadsheets, imagine that's like your data frame, right? It's really obnoxious to look at everything with 50 columns and 20,000 rows or things like that. So you might want to take just specific pieces of it here. And what's nice is when you have labeled columns, you can give it the labeled columns and say, hey, I only want these columns. I don't need to do it by number. Here, your indices we're still going to do by number, right? I want row 0, row 1, whatever here. But your columns you can go by name, which is super handy, right? So we can go through and quickly get, okay, I just want out this piece here, this piece here. There was that, you can download the data. Where did that go? Country data, CSV. Wasn't there a link for that? Did I miss it? CSV. Taxi. Okay, here's the taxi file. Sure, so we can use this one if we wanted, but it didn't give us the example code. So you can download your CSV file, which is essentially like an Excel dump. Right? You save it as CSV. That's a little more common for it to read. And then we just go through and read it all. And you can read CSV. Remember, there's a way to read CSV files specifically, so you don't have to deal with all the parsing and things. Pandas just uses that directly, which is nice. And we go through and do cool stuff with it, which is lots of fun. So you can drop specific things by axis, by label, by column, whatever. You can drop all the duplicates here, which is kind of nice. Hey, I want to remove all the things that are extras, so really common operations. You can insert specific rows, replace rows, sort values by a given axis as well, which is really nice. Fun things in Pandas. Right? Really cool tool. You'll do a lot more with it later. And then MatPlotLib was one of my favorites here. And this one is actually really cool. So let's go import. Oh, we don't need all of this, right? I can probably just delete it all. That's fine. So we're going to import. Now this one, you'd import pyplot. So you get matplotlib.pyplot is the specific module within matplotlib. So a lot of times you'll do it this way. Go grab these here. And then I don't have that one installed yet. Let's go install that one. Oh, come on. Light bulb, install package. And we're not going to do the NumPy stuff right now. We'll just play with this one here. Okay. So there's an interesting scenario here. There's a problem I've given a lot of times before. It was thinking a nonlinear world. Now, the title here is a bit of a giveaway here, but that's okay. So this was a Harvard Business Review article. Wow, this is years old now. Goodness. But the puzzle's still fun here, the thought exercise. And what we're going to do is we're going to use MatPlotLib to visually explore this to give us a better answer here instead of just trying to be intuitive. So the idea here is we manage our fleet of company cars. Sure. We have a bunch of SUVs that get 10 miles a gallon, and we have a bunch of sedans that get 20 miles a gallon. The cars all travel 10,000 miles a year for all of our agents, whatever they happen to do, no matter which vehicle type they're in. So we have money now to replace one of them because we want to become more fuel efficient and save us money eventually, right? Because gas, things like that. We can replace either the SUVs or the sedans. And as we get new ones, right, things are more fuel efficient. So if we replace our SUVs, the new SUVs will get 20 miles a gallon. So we've gone from 10 to 20 miles a gallon. Or if you replace the sedans, we're going from 20 to 50 miles a gallon. Maybe it's some sort of hybrid here, I don't know. So which one is better? Which one will give us more fuel savings? Think about it for a second. What do you think?
Honestly, it's sedans, but I feel like it's a trap.
It is, yeah. I mean, the title kind of gives it away here. So it seems like, hey, going 20 to 50, that's a much bigger gain. We're gaining 30 miles a gallon of efficiency, right? Versus just saving 10 miles a gallon of efficiency as we go. So just off the bat, we're like, oh yeah, this one must be better. Look, the numbers look bigger. Right? This is kind of the way we think about it here. But what we can do is we can actually graph this out, which is really cool. So we're going to make, this is our sedan. We'll go SUVs. SUV, well, you said sedans first. So we'll go sedans. This is gallons used. So our gallons used is always 10,000. I'm sorry, no, this is miles. Sedans, miles driven. Miles driven is always 10,000, right? And then our sedans current MPG, right, is 20 miles a gallon. And then sedans, I don't know, future MPG was 50. So we want to see how much fuel we're going to save as we increase our efficiency here, right? So right now I have so gallons used is going to be, this will be sedans, right? Sedans, gallons used. Sedans, gallons used. We'll start off as a list here, and we'll fill it up here. So we're going to go from 20 up to 50 and see how many gallons of gas we're using at each level, or at each increment here, assuming, you know, this way we can picture it as we go. So for, I don't know, MPG in range, and we're going to go from the sedans current to the sedans future plus 1, so we include the value, right? We want to get all the way up to 50 here. We're going to take our sedans gallons used, and we're going to append then our sedans miles driven divided by the MPG. Right? So we should get out, okay, so 10,000 divided by 20, 500, I think. Sound right? 5,000? No, 500. 500. Thank you for math folks in here. Right? And we'll just keep on going and calculating, and we'll get a list of values back out when we're done. But it'd be nice to be able to plot that, right? So if we want to plot it here, we're going to call plot. So PLT is our shortcut name, so we don't have to type out this whole thing every time here. And what we want to plot then, we're going to give it a bunch of things, right? So I can never remember all the different orders as we go here. I'm going to go back and take a look real quick. So we give it the X and then the Y, is that right? We give it an X-axis and a Y-axis? Yeah, X and Y. So the X-axis that we want to plot here then is going to be my sedan's gallons used, right? And then the Y-axis, we want to be our MPGs, right? So we want to go from 20 up to 50, essentially. So we can just go range from 20 to 51, essentially, or we could copy this one in if we wanted here, right? I guess we'll steal that. I feel bad having the same code twice, but that's okay. And then plot.show. So when you show, it will actually show up on the screen. Again, it's not very pretty or anything yet. We're just putting some data here. So we can see, okay, so we went from 50 gallons of gas, right, per vehicle. Is that? Something's not right with that. Hang on. Miles driven. I have the wrong direction here. Sorry. This is the X-axis, sedans gallons. Maybe I'm confused with which axis here. I thought it was X and then Y. Let me try this. Let me try that way. Okay, here we go. This is better. It's weird we gave it. Okay, I had the gallons wrong. So I wanted MPGs on the x-axis. I did it wrong. So I wanted to show as the MPGs increase. It does do X first, but I had the wrong one in my head here. Okay, so we start at 500 gallons of gas per sedan as we go. And as we increase our efficiency up to 50, we go down to 200. So we're going to save 300 gallons of gas with this change, right? And we can see that it's not linear. Right? And that was the hint from the title of the article here. So what we want to do then is we can show gallons saved. Right? So we can also plot that as well. So we can have a gallons saved. Make a sedans gallons saved is a list here. Now we know the base here was going to be 50. Right? Or I'm sorry, 500. So what we're going to do is we're going to take our sedans gallons saved. We're going to append this calculation. Right, it was going to be our sedans miles driven divided by the sedans current MPGs, sedans current MPGs, minus that. So how many gallons do we save? Right, none to start, and that should increase as we go here. So we also want to plot that same thing then. Let's give it another plot. This is on the gallons saved. And is it a label, a title, label? I forget, what do we call this one? Label. Gallons saved. I think it's label here. It's been a little while. Labels, gallons used. Let's see if that works for us here. Nope, that label was bad. Maybe it's title. I forget. There's one of these things here. So graph looks a little weird here, but right now we're starting at 0 essentially on the axis. Here. So we start saving nothing, and we start increasing our savings here as we go up to a savings of 300. Pretty cool, right? So we can see the savings. So that's for sedans. So we essentially want to repeat this whole thing here for SUVs. So I'll just copy paste, right? That's okay. And we'll have our, you probably actually use the same, that's okay. Sedans, let's be SUVs, miles driven, SUVs. I'll just replace this a bunch of places. Subs. He doesn't like my SUVs, so that's okay. Probably could do this better with using different variables, or the similar ones, but it's okay. All right, so we got all of those. Now I want to plot in those ones. Let me see, how do we label a plot? MatPlotLib, plot label line. What do we call it here? Place inline label? I don't want inline labels. I just want to name the label. Line chart. Oh, goodness. Plot line name. So name different lines in the same plot. Label. Okay, it does say label. Did I do it wrong before? That's weird. I really thought I did it. Didn't I try label before? Oh. Okay, maybe did I have my comma in the wrong spot? Label equals, this is sedans, gallons used. Let's try one label. No. Ah, I need the legend. That might help once we add it here. Try a legend here. Label sedans, gallons saved. Okay, if you had a legend, there we go. Now the labels actually show up. So this works a little bit nicer here. All right, so we have this, and then we'll add in our SUVs as well here. Now, this one here doesn't start at 10 or at 20 to 50. This one goes from 10 to 20. So our plot's going to be a little weird here if we try and throw these in. Let's give it a shot though and see how it goes. Let's go take those ones. So you have our SUVs, current to SUV's future, SUV's gallons used, SUV's gallons used. I don't know why it doesn't like our SUVs. I guess that's not a good word, is it? Subs. Gallons saved. Future. And here. Okay. Getting closer. Let's give it a shot. Hey, okay. Again, looks a little awkward here. I'm trying to put all these plots here. Maybe we could do them in 2 separate plots if we wanted, but so those will work for now. So we can see at 10 miles a gallon here, we're not saving any fuel, but by the time we get to 20 miles a gallon, we've saved 500 gallons a year versus our savings of only 300 going from 20 to 50. And like you'd expect, it creates the same arc, right, of this is just the fuel efficiency essentially here, you know, how many gallons you're using. So we can see, though, and visually illustrate, without too much trouble, a little bit of back and forth here, a little bit of Googling, but that's okay. Always got to Google stuff. Which one was better? Is it clear which one's better from this terrible picture? Should we do 2 separate plots? You can make multiple plots. You want to do multiple plots, or can you tell from this one? You all are just tired. You need more coffee. It's good for you. Okay, so playing around MatPlotLib. We get lots of fun things we can do with here. We want to label some axes too, right? So how do we do, let's just Google it here. MatPlotLib, label axes. How to label the axis. You can set X ticks. Oh goodness. Oh look, you can set your legend location. That's fun. X label. Okay, so X label. So we want plot dot X label to be, this is MPG, right? And plot dot Y label. We're plotting 2 different things on that label, so I can't really call it gallons. I guess it's gallons, right? Gallons saved versus gallons used. We'll try it. Plot dot Y label is gallons. No, cool, now we added it. Now the other fun thing that you get here with MatPlotLib is you can save the figure. You can say, hey, I want to save this picture as a PNG. So if you ever want to add cute little graphics, you don't even have to take a screenshot, you can just save it off, export it. You can actually do that right in your code as well, if you want. So you can have it chart something and save the file immediately, which is lots of fun too. So like, especially if you're doing like, hey, I want a daily report, you can just run it, dump something out, run it, dump something out, and get a bunch of pictures and add them in and do fun things. All right, so again, just some basic line plots here. Those are not super interesting here. The MatPlotLib library does all sorts of amazing things here. You can do really cool things. Look at that, you can add text, you can annotate, you can set your legend. There we go. Is there a drop? That looks like a pretty decent drop, right? You can give it different line colors or markers if you want here, so they don't all have to look like straight lines. You can give it some fun things for styling, right? Different stylings, different options here. You don't even have to connect your dots if you don't want. So almost if you can imagine it, there's probably a way to do it, which is fun. So I like the MatPlotLib library. MatPlotLib, just their website with all the examples is really cool, because they'll show you some cool things here, right, on different ways we can do it here, doing contours or meshes. These are really fun. So look around, play with it sometimes, and you can just go run them all too, which is really nice here. You can see all their examples in source code if you want to look at an example of it here. The chatbots are pretty good at plotting things nowadays as you go, which is a nice little helpful tool there as well. We'll do more plots next semester. So for our projects, we'll look at plotting some of the data that we're coming up with here to make some sense of it. This picture's really are worth 1,000 words. If you can visualize something and show someone something, it's a little easier for them to understand. I know all of you really love data and numbers, so I can show you a spreadsheet and you're like, oh yeah, I get it here. But most people need pictures, right? We don't all think in numbers, that sort of thing here. So MatPlotLib is really cool. Let's see. And there was one other library. They used to have a module for it. I think they took it out now. Is it in additional? Where did it go? If I search, I can search TKinter. This is a really fun one. Okay, an additional material. 17. So there's basic graphics here. This one is really fun. You can build a program that actually has a window with buttons to click on. So finally, we can get away from having to type stuff in the black box, the console programs. Because almost no one uses, most end users don't use that. Developers and other programming computer type people will do a lot of stuff at the console. It scares most people just because it looks complicated. But you can actually build out a cool program with buttons and labels and things to click on, which is really fun. So here's an empty frame. Right, we can do that. Here's a slightly more interesting one. You can do 2D graphics. Where do they have the one with the button? Didn't they give us one with the button? So you can draw your own I don't recommend drawing your own histograms. This sounds terrible, but you can do it yourself if you want. Here. Oh, where is it here? Color chart. Oh, we don't want that one. I thought they had the one with the button. We can find it here. So TKinter. Hey, well, let's just Google it. Let's go ask the chatbot. Let's do the UM one, right? Why not? Create a example TKinter program with a button that displays hello world when clicked. See if we can figure this out. I think it can. They're pretty good at these. All right, let's give it a shot. Oh, this was Lyra's. I should keep some of that, shouldn't I? Shoot. I don't want that one. So we just do another file here. Let's do a new Python file. Just visual, I don't know, Windows. All right, so let's see if we can run this one here. Do I already have TKinter imported? Nice. I must have done that one already. So I get a little window, and I can click me, and it says hello world. Yay! And you can make it bigger or smaller, kind of is adaptive to where it is here, which is fun. So puzzling through it's not too tricky here. It says, hey, I want to put a button in here. Here's its text here. And what it does is you give it the name of a function. Remember, functions you can also pass, this is way back when we talked about functions, so you can pass it the name of a function, and then when it's clicked here, it runs this code. So it goes and finds the label, sets its text to hello world, right, which is fun. So let's do, let's add a text box. A text box. The user can type in, set the label to the text. Entered. We'll give this one a shot. Look at that, it's even telling us what it's doing here. How fun. These are fun to play. I don't know if you play with the chatbots a whole lot, but they're pretty fun. Let's try this one here then. All right, so now there's this thing called entry, right? So we're getting the value off that entry. It'll place a little box to type into here. So we'll get their value, and then we're gonna set the text to whatever they typed in. So instead of hello world, here's a little box here, so I don't know, happy Wednesday. And then we click our button, and it sets this label here to that. Right? So again, our label starts as empty here. We're just throwing it in. And when we click our button, we get it. So you can do sorts of fun things here with creating applications that have text boxes and labels and buttons and not having to type stuff into the console, which is really nice. And do all these sorts of things. We get, hey, enter the name of a file or do other sorts of things here. We can go load files out of this here as we go. I wouldn't recommend you try this for your Monopoly game, but it would be a stretch goal if you wanted to play with it. You could build a little Monopoly window and show visually on the board without too much trouble. Here's where you are, here's where you are, here's where as you move around here. You just have a bunch of labels. So not too tricky. We'd add a bunch of labels, you'd access them by index. Hey, you're at position 3, here's the label at position 3. This sort of thing. You can do all sorts of fun stuff with it here as we go. So TKinter is really fun as well. So that one is the optional. And again, you can draw stuff if you want. I don't think drawing things is super interesting, but you can do other shapes, rectangles and ovals, and draw lines or different given polygons. All sorts of fun ones here to draw shapes. And you know, you can build a silly little game out of it here. I always like games, so building silly games makes me happy, that sort of thing. So TKinter is out there as well. Yeah, I think we're doing pretty good. Broadway show scatterplot. Does this one have our code in it? Or is this just this is the lab, right? You got a couple labs to work on. Yeah, so you can go and get the data from the CSV file, and you want to save it as a figure as we go here, which is really fun. So it'll show you it all as we go. So a couple practices for the chapter. Not too much. We probably don't need to do all of these, right? Let me mark some of these as optional. Let's do, I don't need the multiple plots. Let me make this one optional. No, hang on. I have to go back to configure. Configure it here. There we go. So I'm just going to move this out. Let's move it out to 17. Put it in here. Did it move? No, move into 17. Okay, move that one out. I think the other ones are pretty quick here. Some statistics here. You know what, skip the other scatter plot, why not? Just do a basic line plot, and that should be fine. Okay. All right. So do you want me to, I was gonna run SciBooks today, right? Or do you want it next week, just to see what your progress is? I guess I was gonna do it today, just so you see where you're at. I can finish entering the scores for your projects here, so I'm a little behind on that. But we're doing pretty well. This should have been optional. Hang on. Goodness, configure. Because I dragged them in and stopped marking it as optional. Let me go back. Mark as optional. There we go. Okay, now the whole thing should be optional. Come on, save. All right, I'll make sure it's optional. I won't even check chapter 17, so don't worry about it when I run the report here. So I'll run that for you. I'll plug those in so you can see where you're at. But that concludes the semester, essentially, of content. We're going through a lot of fun things. So all next week is reserved for working on the final project. So I'll show up, you got questions, help you with it. Lab time again for the project, same as next Wednesday. And then we are presenting in 14 days, so 2 weeks from today, we present, right? For the final project. If you got questions, please reach out and ask. Again, give it a good half hour to an hour of trying to struggle through and find your own answers. Use your resources to try and figure it out, but after that, just reach out and ask. Text me or find me on Discord. That's usually pretty quick. Emails come to my phone too, but I don't always see them quite as fast. So reach out. Happy to help get you unstuck. I'm not going to code it for you, but I'll get you pointed in the right direction so you can keep moving on it, make some progress. It's a really happy day when everyone presents a working project. That's really exciting. It's not a lot of fun when people have to get up in front of class and show a half working project. So don't do that, right? Let's try and get this across the finish line as we go. All right, questions, thoughts, concerns? Yeah.
Is the presentation here in this room?
I don't know if they've assigned rooms yet. They assign rooms at some point. Let's see. Where did it go here? So that's for scheduling. No, I want the fall. Hang on. Fall. For final exam schedule? Nope, that's the wrong one. I thought they had a list here, right? Final exam. That's for scheduling. Is it in the calendar? Calendar. I found it before. Where did I find it? One stop is not helpful. Wasn't it on final? Okay, here. Final exam. That's the policy. Where's the schedule? I swear I found it before because I got the date here. Final exam schedule. My Google's just not working here. That's weird. That's summer scheduling. Why are we not getting it here? End of semester. Maybe this will give us a link here. Final exam schedule webpage. Final exam schedule. Final exam study days. Oh my goodness. Okay, I'm assuming it's just not assigned yet, because I'm not finding. Oh, here's the schedule, but they don't have the rooms yet. Okay. So we know what day, probably in here. Sorry, that was a long trying to find answers that aren't out there yet. Yeah.
I wasn't sure if you said this before, but if you are working with a partner, you each have 10 commits for unattended.
10 total's fine between the two of you.
Okay.
Yep.
So like you have 7 and 7.
Yeah, that's great. Yep. Yep. Yeah, because we've got 2 more weeks to get it done, so we've got time to get 10 more commits, even if you haven't even started yet, which I'm sure you've all started. Right, just smile and nod, pretend, if you haven't yet. Okay, thank you. We got time to get it done. Right, little bit by little bit, I want to get it across the finish line. If you're done next week, by the end of next Wednesday, because we've had study time and time to do it in class, that's fantastic. I would love for you not to have to worry about it when you have other final exams. But again, you make your own schedule, you can figure it out, so I'm happy to do that. Right, anything else?
This is more individual, but I wasn't sure if you merged the repository for my partners.
So there's no way to like merge it, but I give someone access. I'll take a look and see.
Yeah.
Yeah, I'll take a look.